we're looking at the bullseye question. A darts player knows that her chance of scoring a bullseye on any one throw is 0.1. Find the number of turns she would need to ensure a probability of 0.9 of scoring at least one bullseye. So we know that we're going to be looking at the bullseye situation. We've got a series of trials, that's the throws, and they're independent. The probability of success remains the same on each throw. So let's write down the probability of X successes. So if we let X be the number of successes in N trials, we have that probability that X equals the sum number X is going to equal N choose X multiplied by the probability of success to the power X multiplied by Q, the probability of failure, to the power N minus X. Okay, so the question gives us that the probability of success, probability of a bullseye, is 0.1. And we know that probability of failure is just the complement of that. So we're going to get Q equals 1 minus P, which is equal to 0.9. And so what we want to find out is what is this N? Okay, so the question asks us the probability that X is greater than equal to 1 must be greater than 0.9. Okay, so if we look at this equation we've got up here for probabilities, that gives us the probability when X is equal to some number, not greater than equal. So we need to change this formulation somewhat down here. And what we can use is the fact that at least one bullseye is going to be the complement event to getting no bullseyes in N trials. So what we can put here is 1 minus the probability that X equals 0 is greater than 0.9. So here our left-hand sides are equal. So now we can just substitute in the formula we've got above. So we've got 1 minus N choose 0 multiplied by 0.1 to the power 0 multiplied by 0.9 to the power N minus 0, and that's got to be greater than 0.9. Okay, so let's simplify that a little. So we've got 1 minus N choose 0, that's just 1. 0.1 to the power of 0, that's just 1 too. So we've got actually just got 1 minus 0.9 to the power N must be greater than 0.9. Okay, and let's start trying to isolate this N because that's what we want to solve for. So what we're going to do is we're going to subtract 1 from both sides. So over here we're going to get negative 0.1. So we've got negative 0.9, negative 0.01. I'm going to make those positive and just flip around this inequality. That's to the power N. Okay, so now we've got N is up here, that's our exponent, so we're going to take logs of both sides. So log of 0.9 to the power N must be less than the log of 0.1. So we can use our log laws and just take that exponent out the front as a multiplier. So we're going to get 0.9 must be less than the log of 0.1. Okay, so now we can just solve for this N. So we're going to divide both sides by the log of 0.9, remembering that that's less than 1, so that must be a negative number. So we're actually going to switch around the inequality again, because now we're going to have a positive number on both sides. So we have log of 0.1 divided by the log of 0.9. And so finally, when we work this out, we get that N must be greater than 21.5. So if we're going to round that up, because you can only throw whole numbers of throws, we get N has to be greater than or equal to 22. So therefore, the darts player must throw at least 22 throws to be sure of getting a 90% chance of scoring at least one bullseye.